Yesterday we talked about a new operation. We've talked about addition, subtraction, division, multiplication. We've talked about powers. We've talked about absolute value. Who can tell me the new operation we talked about yesterday? Great. Hint, it started with a C. It rhymes with composition.
Composition.
Yeah, we talked about composition. Composition was that little circle. It was a new operation. We told you what to do with it.
Did you notes or something?
Wait,
Yeah.
I have these notes.
Okay, thank you. Today you learn a new operation for functions, and it is called inverse. It looks like -1 power. But to be clear, F inverse of x is not 1 over f. That's not what it means. It's not very complicated once we do it, but I'll tell you what it means in a second. Before we talk about function inverses, there's only certain functions that have inverses. Some don't, and some do. So the functions that have inverses are functions that are what we call 1-to-1. A function is said to be 1-to-1 if every output has exactly, every input.
Oh, come on.
I'm sorry.
That was good handwriting.
Yeah. Every input has exactly one output. And every output has exactly one input. All right, so we'll talk about, you don't have to write this down, we'll talk about Keaton and Spencer here real quick, okay?
Oh, sure.
Okay, hockey players, right? Suppose, is it possible in a hockey game for Keaton to score 2 goals and Spencer to score 1 goal?
Yes.
Yes.
Yes. Is it possible for Keaton to score 3 and Spencer to score 4?
Yes.
Yes.
Is it possible for Keaton to score none and Spencer to score none?
Yes.
Yeah, that's possible. Is it possible for Keaton to score 1 and for Spencer to score 1 and 5?
No.
No.
That's not possible. Every input has to have exactly one output. In this case, it has 2 outputs. That's not possible, so that would not be a function. Now, here's the difference. You guys told me it's possible for Keaton to score 3 and Spencer to score 3. That is a function, but it's not a 1-to-1 function. Because if I asked you which is the player on the team that scored 3 goals, you would give me how many answers? 2. It can only give me 1 answer. Note if I switched this and I said, okay, Keaton scored 5 and Spencer scored 7, I said, which is the player that scored 7 goals? You would tell me Spencer. So when each input has just one output and each output has just one input, then it's what we call 1-to-1. And graphically speaking, how we model that, it's not too tough. The red one is a 1-to-1 function, and the green one is not a 1-to-1 function. And I'll show you why. I'm going to grab my vertical line here, and I'm going to drag it across. Okay, come on. Come on. Where are you? There you go. All right. Vertical line. Do you agree that these both are functions, that they both pass the vertical line test?
Yes.
Okay, but if I grab a horizontal line, the red one passes the horizontal line test, doesn't it?
Yep.
But does the green one? No. So the fact is, in order for a function to be 1-to-1, it must pass the horizontal line test as well.
So must pass the vertical and horizontal?
Yes. So we're going to mix things up a little bit. Grab your homework right now. Let's look at the first 3 problems so you can get them done right now. Okay, your homework that looks like this right here, function inverses. You have 3 graphs. Go ahead, take a minute, and decide, do they pass the horizontal line test, yes or no? After you come up with an answer, share with your friend. Let them know what you think.
I don't think the first one.
Yes.
No, yes.
Is there the second one done?
Wait.
No, yes.
No, yes, no.
Take about 30 more seconds.
It's like this.
Oh, maybe you're neck.
I don't really know. I don't really know. No, this one does, because if I ask
5, 4, 3, 2, 1 is the first one. What does the first one pass the horizontal line test?
No.
No, it doesn't. Does the second one?
Yes. No. Does it, is it both lines?
Yeah, it's got to pass. You know, you see that part and that part. As you draw a horizontal line, it crosses in 2 spots, doesn't it?
I thought it was only one line at a time.
They are the same one.
Got it.
So that will be a no as well. How about the last one?
No.
That's a no as well. Good. Look at that. You got 3 problems done your homework. How's that? So we move on to inverses. In order for a function to have an inverse, it must be 1-to-1. And here's what a function inverse is. It's very, very simple. It's just new. For function inverses, the domain becomes the range, and the range becomes the domain. We'll make it easier. The x's become the y's, and the y's become the x's. Okay? So to produce the most basic example, I'm going to give you an example of a function. The function is the coordinate 3, 8. It is one of the most boring functions known to mankind. It's just a point, right? That's all it is. And we can use our knowledge about functions to say f of x is equal to y. Everybody recognize that this is x and that gives us y?
Yeah.
That's what we've always done when we've done function notation, agreed? So for x, if I plug in 3, f of 3, if I have an x value 3, what is the y value that it produces? 8. Everybody good with that? So when you do f inverse, okay, of something, say I do f inverse of 8, what that means is this is the y value, okay, and it produces an x value. So instead of saying if you plug in 8, what's the output, the idea is 8 is the output. What was the input that gives you 8? 3. So you get the output. What is the input? Look at example 1. It says f of 2 is 3. So that means that that's an x value, that's a y value. F of 1 is 9. That's an x value, that's a y value, so on and so forth. It's asking us f inverse of 8. So what that means, if we have a y value of 8, what is the corresponding x value? Negative 3 is the corresponding x value. F inverse of 3. Yeah, if the y value is 3, the x value is 2. F inverse of 5. 4. And F inverse of 9. It's no big deal, right? Pretty straightforward? Good. Let's change it up just a little bit. It says given f of x is 3x minus 8, or in other words, y equals 3x minus 8. F of x and y can be interchangeable. It's asking us to find f inverse of 6. We don't have a coordinate in this situation. But we do know for our coordinate, it says f inverse of 6. Does that mean 6 is the x value or 6 is the y value?
Y.
6 is the y value. You are trying to find the x value. Anybody guess what we do to come up with the y value or the x value? Plug in 6 for y. So we get 6 is equal to 3x minus 8. Now what?
Add the 8.
And I get 14 is equal to 3x. Divide by 3, and I get x is 14/3. Not too bad, right? Instead of just finding a singular answer, we can actually write a function for a new inverse. So for example, this one is y is equal to 2x minus 5. That's f. Okay? That's function f right there. What I would like to do is write a rule for f inverse. And it's not too bad. All I do is I take the x and the y's and I switch them. So I put an x and I put a y. And then I go ahead and I solve for y. This is where first hour got a little bit contentious, a little bit lost. Can somebody tell me what I do to solve for y? I want just y equals. What should I do?
Add the 5.
Add the 5. I want to solve for y, so what should I do to both sides?
Divide by 2.
Divide by 2. I divide everything by 2. Maybe this is kind of where I lost people. You have a few options here. You could either write x plus 5 all over 2. That would be one option. Okay, you could do that. Or you could divide each one of them by 2 and write 1/2 x plus 5/2 is equal to y. Either way is fine. Those are the same expressions. So it turns out that function f is y equals 2x minus 5. F inverse is y equals 1/2 x plus 5/2. Okay, those are inverse functions of each other. What I would like you to do is I would like you to go ahead and find the function inverse for 6 minus 4x. Go ahead, find the function inverse for 6 minus 4x. Okay, I subtracted the 6. I got x minus 6 is negative 4y. I divided by negative 4 to get x minus 6 over negative 4 is equal to y. Now you could write it like that, or you could divide them both by negative 4. So negative 1/4 x and then plus 3/2. Can I just get a show of hands? Raise your hand if you would prefer to write it as number 1. Who would prefer to write it the first way? Raise your hand if you wrote it as number 2. Okay, all right. Either way is just fine. Flip it over. You got these finished off, then you're going to have time to work. Got f of x is x cubed plus 1. I want to find the inverse. So the function inverse is going to be when I have x equals y cubed plus 1. I want to solve for y. What do I do to solve for y? Subtract the 1. X minus 1 is equal to y cubed. How do we get rid of a cube? How do we get rid of a square? Square
Root it.
square root it, right? So the way you get rid of a y cubed is you cube root it. And you get the cube root of x minus 1 is equal to y. The next one, to find the inverse, we have x equals y over 5. I want to solve for y. What should you do to both sides? Multiply by 5, and you get 5x equal to y. Turns out that x over 5 and 5x, that those are inverse functions of each other. Not too bad? Okay, last part, flip back to your notes. We want to test to see if something is an inverse. And the way that we test to see if something is an inverse, I'll give you an example. In addition, there's a number that's the inverse of positive 3. And that number is negative 3. And those are inverses of each other because when you add them together, you get 0. But to see if functions are inverses of each other, what we do is we actually compose them together. Oh, we're going to use what we did yesterday. If you compose two functions and you come out with x, then they are inverses of each other. But it's not enough to just compose them f of g. You also have to compose them g of f and get x as well. A lot of people saying fog and goth first hour. What do you prefer, Sydney? Fog or goth? Goth, okay. All right. Well, teach their own. What do you prefer, the right Twix or the left Twix?
I have the same thing.
No.
How dare she? That, I don't feel safe in the classroom anymore.
Wow.
They're the same? She said they're the same.
What's the difference?
The right one has more.
Okay, I'm like, all right, some people are leaving class tomorrow.
right one,
That's all I have to say.
I
All right.
won't show up, Mr. They're the exact same thing.
The right one has more caramel.
Then the right.
Okay, then I like the left one because I don't like caramel. So I don't eat Twix. Well, there you go.
You're crazy.
We are going to use the property inverses to determine if these are in fact inverses of each other. The way that you determine if something is an inverse of each other is you compose them. And if you remember yesterday when we did f of g, what we did is we took g and we substituted it right in for x within the f function. Okay? That's what we did yesterday. And so you had a 3, and then instead of x, we wrote x plus 5 divided by 3. And then we had the minus 5. I'll pause there. Is anybody confused about what I just got there? Yes.
I wasn't here yesterday, so like, is like the fog, like, is that like times or
Nope.
like the degree of g?
Nope. It's
Oh wait, I'm on the homework.
it's not like multiplication. It's not like addition. It's not like exponents. It's something entirely different.
Okay.
I would say in order to understand, you're gonna have to watch a video from yesterday, okay? Which is uploaded. All right, so these will always work out pretty nicely. What reduces here? Anybody see what's gonna cancel?
Not the threes.
The 3's are gonna cancel, right? The 3's are gonna cancel because 3 over 1 and then 3 on the bottom, those are gonna cancel, and I'll be left with x plus 5 minus 5. And now, x plus 5 minus 5, you're left with x. That's what we wanted, isn't it? Exactly what we wanted. Now, it's not enough to just compose it that way. We have to compose it the other way. So we're going to do g of f. So you're going to take what f is right there, and you're going to drop it in for x over on the g function. And so you get 3x minus 5, and then notice there's a plus 5 divided by 3. Now, it's very, very, very important that you recognize, that you recognize what's going to cancel first. Are the 3's going to reduce first, or the 5's going to reduce first? The 5's are going to reduce first, okay? So as you add and subtract those 5's, you get 3x on top, and you get 3x on the bottom. And 3x over 3 is just going to give you x. So because you got x in both situations, they are inverses. I saved our easiest example for last. We have f of g. We're going to take what g is, which is this guy right there, and we're going to plug it in right over here for x. And notice we get the cubed root of x, and we are going to cube that. What happens if you cube a cube root?
It cancels out.
Cancel and leave you with x. And if I switch it, g of f, now I'm going to take what f is, and I'm going to drop it in right here for g. And I get the cubed root of x cubed. Notice how they're written differently? But still, a cubed root and a cube undo each other, and I get x. That's exactly what I wanted, so yes, they are inverses of each other. And that's that. You guys have some good time. The answer key's up on the board. You can probably finish it in class. And you will not have any homework for Alana's birthday party tonight. Alana, you're inviting the whole class over. Thank you. And what are you feeding them tonight?
I'm going to Olive Garden.
She's bringing you all the Olive Garden. I'm getting the tour of Italy. Sign me up. Endless breadsticks and that great potato cheese soup that they sell. I can't remember what it's called, but it's really good. Makes my stomach happy. Thank you, Alana.
You were gonna have